Hello, and welcome to a new unit on exponentials. To start, I want us to go back to some of the basics for using exponents, and we're going to start with this. We have two blanks here, one at the bottom and one at the top. The bottom is sometimes called the base. The top here is sometimes called the exponent, and you can put any numbers you want in there so that when you actually calculate it, you get a total of 64. And I want you to see if you can find more than one solution. So go ahead and pause the video and give this a try. All right, some of you might have come up with the cheater answer, which is 64 to the power of 1. If you came up with this, good job, good job. Anything to the power of 1 is just itself, so 64 to the 1 works. But if we tried something else, for example, 8 to the power of 2, that's going to also give us 64, because 8 to the power of 2 means 8 times 8. Which is 64. If we were going to try a smaller number, maybe 4, we could do 4 to the power of 3. That will also give us 64. If we did 2 to the power of 6 with a bit of guess and check, that would also equal 64. And there's one more answer that I've seen students come up with, 4,096, if we actually put that to the power of 1/2. Remember, 1/2 means the square root written as an exponent. That will also give us 64. All right, awesome. Hopefully you had a fun time working on that little puzzle. Let's look at something else. We're going to use the digits 1 to 9 at most once to fill in the boxes here. So this is another base and exponent. And over here we have a 3-digit number. So this is a 3-digit number. Now, you can't repeat digits, so basically you're trying to find something to the power of something that gives you a 3-digit number, and all of them should be different digits. So go ahead and pause the video and give that a try. All right, assuming you gave it a try, 3 to the power of 6 is one answer. 3 to the power of 6 will be 729. Notice how we're using all different digits. But there's another one as well. 8 to the power of 3 will be 512. Now, if you found a different one, go ahead and post in the comments below, but these are the two that I found. All right, one more little puzzle with the boxes. Here we're going to use the numbers 1 to 20, because there's so many boxes. You can't repeat numbers, and you need to fill in the boxes so that everything here is equal. So here we have 2 to the power to the power. Here we got 2 to the power divided by another thing, 2 to the power times 2 to the power, and 2 to the power divided by 2 to the power. And all of these should be the same. So pause the video and give it a try. All right, assuming you gave it a try, but if you didn't, I'll give you a quick hint. One solution is to aim for a total of 2 to the 12. So that's your goal. For example, over here, if I did 2 to the power of 10, let me do that in another color. 2 to the power of 10 and 2 to the power of 2. We know that when we have the same base, we add the exponent. So this is 2 to the 10 plus 2, which is 2 to the 12. And that's one way of getting kind of our goal. So if that helps, pause the video and give it another try. Over here, we have 2 to the 3 to the 4. That will also give us 12. Because we know when we have power to a power, we multiply. So this is 2 to the 3 times 4. 2 to the 12. Here we can put 2 to the 19 to the 7, because we know when we have two powers divided, we get to subtract them. 2 to the 19 minus 7 is 2 to the 12. And over in this really messy one, we could do 5 and 12 and 6 and 8. Because first we have to do power to a power, so that gives us 2 to the 5 times 12, divided by 2 to the 6 times 8. Now 5 times 12 is 60, and 6 times 8 is 48, so that's going to give you 2 to the 12. So all of these are 2 to the 12, if we look here. We've got 2 to the 12, 2 to the 12, 2 to the 12, 2 to the 12, so they're all equal to one another. And what I was hoping you would gain from this little puzzle is those exponent rules. So just real quick, in case you forgot, we'll write it with a 2, but it works with any number. 2 to the power of 1 is 2. 2 to the power of 0 is 1. Anything to the power of 0 is 1. If you have 2 to the power of 3 times 2 to the power of 4, you get 2 to the 3 plus 4, which is 2 to the 7. If you have 2 to the power of 3 all to the power of 4, then you get 2 to the power of 3 times 4, which is 2 to the 12. That's where when you have the power to a power, you multiply. If you have 2 to the power of 4 divided by 2 to the power of 3, that's going to be 2 to the power of 4 minus 3, or 2 to the 1. I guess another exponent rule that we didn't quite mention here, but if you have 2 to the power of negative 3, that's the same as 1 over 2 to the 3. These exponent rules are going to be really crucial in our upcoming units. So if you haven't seen these before, or if they're just a little bit rusty, go ahead and Google exponent rules and watch a video, try a few problems until you feel comfortable with them. All right, so with our exponent rules out of the way, let's try a problem. If we know that 2 to the power of x equals 4,096, could we find out x? And assuming we have a calculator handy, so let's say, yes, we have a calculator. We're going to use a calculator. We could just guess and check. So let's try 2 to the maybe 6. That means 2 times 2 times 2, right? 6 times. And we could try that on a calculator. That's going to give us 64. That's a bit too low. Maybe let's try 2 to the 20. 2 to the power of 20. Oh, that's going to give me 1048,576. That looks a bit too high. So somewhere between 6 and 20. Let's try 2 to the 12. 2 to the power of 12 is, oh nice, sniped it, 4,096. So the answer is x equals 12. And that's pretty good, right? Guess and check, we've got the answer. But what about something like this? If we know that 512 to the x equals 64 to the 240, can we find x? And you're welcome to use your calculator, see what you come up with. Well, you're probably going to come up with something that doesn't really work. If you take 64 and raise it to the power of 240, you're probably going to get an error. And that's because your calculator is just not capable of calculating that large of a number. 64 times 64, 240 times, is going to be so large that your calculator can't handle it. So what are we going to do? How are we going to guess and check at the right x value? Well, the thing is, we're going to need another method. And instead of trying to guess at the x, what I want to do is look at that 512. The 64 definitely. Could we write these as powers of 2? 64, I think that's a power of 2. If you think about powers of 2, right, these are like the sizes of phones. Powers of 2 are 2, 4, 8, 16 gig, 32 gig, 64 gig, 128, 256, 512. Hey, look, I think these are both powers of 2. This is 1, 2, 3, 4, 5, 6. Okay, so 64 is 2 to the 6, 7, 8, 9. Okay, so this is going to be 2 to the 9. So let's rewrite this equation in terms of powers of 2. So 2 to the 9 to the x equals 2 to the 6 to the 240. Now, power to a power we multiply, so this is 2 to the 9x. This is 240 times 6, so 1,440. And the thing is, if these are both the same, okay, if we have right here a 2 and a 2, if these are the same, there's only one way this could be true. It's only true that these two are the same and equal if 9x is equal to 1440. In other words, if we have two exponents, two exponentials, right, where we have a 2 to the something equals 2 to the something, the only way those could be true is if their somethings are the same. Sometimes you can think about this as like having the same base and then you drop the base. but I don't like to cross off the base because we're not really canceling something. But we can say, yeah, the 9x has to equal to the 1440. Well, now, I mean, this is just sort of regular algebra. Divide by 9, and we get x equals 160. Now that's pretty good, but it's hard to verify on our calculator. So what we're going to do is pull up a computer calculator, Wolfram Alpha, and we're going to see if this works. All right, so here we go. The way you type this in on a computer is you write 512. To do a power, we have this little hat symbol, and then to the 160. So 512 to the 160 is this giant number here. It has so many digits. It says more digits. So we almost would have to click more digits and more digits. My goodness. Okay, so it's some huge number. Well, let's try the other option there. The 600 or 64 to the 240. Let's see if it's the same number. And let's just look at these first options. We have 304 to start. And we know here it says it's 10 to the 433. Let's see if that's the same. All right, so we have 64 to the 240. And yeah, we got that 304 to the start and 10 to the 433. So these are the same gigantic number, and so it is indeed the correct value for x. You wouldn't be able to check this on a regular calculator, but you can with a computer calculator, something that can handle, technically this means 433 digits, which there's no way your calculator could do that. All right, so now we have a bit of a method. We want to make the bases the same, and then we want to equate the exponents, or drop the base. Here we have 3 to the power of 3x minus 1 equals 9 to the power of x plus 2. Now 3 and 9 are not the same. But 9, we could make it the same. 9 is the same as 3 squared. So let's write 3 squared to the x plus 2 equals 3 to the 3x minus 1. Now we need to use our exponent rules to simplify that right side. Power to a power we multiply, so 3 to the 2x plus 4. Because we're taking that 2 and multiplying the x plus 2. So the 2 is going in on both, 2x plus 4. Now notice we have the same base here. We both are 3, so we drop the base. 3x minus 1 equals 2x plus 4. Move the x over. X equals, move the 1 over, 5. And again, if you wanted to check, you're more than welcome to. You'll get 3 to the 15 minus 1, which is 3 to the 14. On the other side, you'll get 9 to the 5 plus 2, so 9 to the 7. I think these numbers are small enough for a calculator. This will be 4782969, and this will be 4782969. So yep, this works out. Going forward, we're not going to bother checking these. It seems like our method works, and sometimes the numbers just get too messy to check. All right, so we got another one here. I'd encourage you to pause the video and give this a try. Okay, so we're going to go for powers of 2 on this one. 64, we can write that as 2 to the 6. And 32, we can write as 2 to the 5. That'll leave a 2x plus 1 up here and just an x. Now we do exponent rules. This will be 6 times 2x, so 12x plus 6. 5 times x is 5x. Then we drop the base and we get 12x plus 6 equals 5x. Move the 5x over, move the 6 over, and x equals negative 6 over 7. You can definitely have a negative as your solution, and there we go. Now, you might not have been able to do those powers of 2 as quickly as me. And so what I would recommend is that you get used to your powers. So let's look at the powers of 2. It would be 2, 4, 8, 16, 32, 64, 128. You should at least know those powers of 2. And if we put maybe some numbers along the top here. All right, that's your first power, second, third, fourth, fifth, 6th, and 7th. Kind of like counting by powers of 2. Similarly, you should be able to count by powers of 3. So 3, 9, 27, 81, 243. I wouldn't expect you to know more than that, but you should be able to count by powers of 3, at least up to 3 to the 5. Let's look at powers of 4. 4 times 4 is 16, times 4 again is 64, and you should know one more power of 4. It's 256. It's kind of like each time the numbers get bigger, I don't need you to know as many powers, but you should know some of them. If we're looking at 5, that would be 5. 5 times 5 is 25, then 125, and you know what, it might be nice to know the next one as 625. Let's look at powers of 6. 6 times 6 is 36. Might be nice to know one more 6 is 216. And from there, 7 and onward, I just need you to know the squares. So 7 squared is 49, 8 squared is 64, 9 squared is 81, and then you're good to go. But this is kind of like a power table. It's not a multiplication table, it's like a exponent table or powers, and you should at least know these ones so that if you see bases, you can recognize, oh, I know what's going to be common. So here's a great example. We have a 27 and an 81. Just based on that table we saw, both of those are in the row for powers of 3. And so we should recognize right away, oh, 81, that's going to be 3 to the 4. 27, that's going to be 3 to the 3. We need to be able to recognize that because this will be in the no calculator section, and we need to know what the common base is so we can eventually drop the base. So now that I've given you the powers, go ahead and pause the video and see if you can solve the rest of the algebra. All right, so we'll have 3 to the 3 here. 3 to the 4 over here. And now we got to be a little careful with the multiplying. 3 times 3, it's a lot of 3's. Negative 9x, negative 3. Here we've got 3 to the 8. So we drop the base. Move that 3 over, so that's going to be 11. Divide by the negative 9. So negative 11 over 9. Again, you can get negatives, you can get fractions. Those are totally fine for answers. All right, here's a fun one. We have 4 to the 5 minus 9x equals 1 over 8 to the x minus 2. There's a bit of a twist here, so pause the video and give it a try. All right, so they're both going to be powers of 2. You can write this as 2 squared 5 minus 9x equals 2 cubed x minus 2 1 over. So this will be 2 to the 10 minus 18x. Not a problem so far. And this is 1 over 2 to the 3x minus 6. But you can't drop the base here. Can't drop the base. Because, and here's the problem, this is a power of 2. This is 1 over a power of 2. They're not both powers of 2. In some ways, this is almost like a power of a half or something. They're not the same. They have to be identical. You couldn't drop it if one had a 2 and one had a 3. Similarly, you can't drop it if one has a 2 and one has a 1 over 2. So we have to do something. And what I would recommend is use that exponent rule with the negatives. So remember here, if we have 1 over, well, let me give you a couple examples. If we have 3 to the negative 7, that's 1 over 3 to the 7. We're used to taking a negative and bringing it to the bottom. But in the same way, if you had a 1 over 3 to the 6 and you wanted to get rid of that fraction, you could write it as 3 to the negative 6, right? You could take the 1 over business and turn that just into a regular base 3, not the 1 over 3. And the price you pay, the consequence, is that you have to put a negative in there. So if we did that with the 2, we could write this as just a regular power of 2. But we have to put a negative in front of that exponent. And because there's 2 terms, we can't just say, oh, it goes from 3x to negative 3x. We have to account for both of those. So we're actually going to get 2 to the negative 3x, but then plus 6. you have to flip-flop both of the signs. Now over here, that's just the same. Oh, let's make sure we don't miss a line. Okay, they're both powers of 2. So now we're good to go. This is going to be 10 minus 18x equals negative 3x plus 6. I'm going to kick the x to this side here. So that's going to be 4 equals 15x. So x equals 4 over 15. All right, we got one more here. 4 to the x over 64 to the x minus 2 equals 1. Pause the video and give it a try. All right, so if you're thinking about powers of 4, you can actually get this done with powers of 4. You could do powers of 2, but I'll show you powers of 4. 4 is already a power of 4, so that's cool. 64, if you remember, 4 cubed is 64. So we'll write that. Then we'll get 4 to the x over 4 to the 3x minus 6. And here we have to do something. We either have to combine these or something. Yeah, I guess we could do that. So this will be 4 to the x minus 3x minus 6. Same base, and we're dividing, so we can subtract those exponents. That'll be x minus 3x is minus 2x, and then minus minus makes a plus for the 6. Doesn't look like, though, we can drop the base yet, because one's a 4 and one's a 1. You know what? I think we could have rewritten that 1. 1 is actually a secret power of 4. 4 to the 0 is equal to 1. Oh, look at that. Anytime you see a 1, you could write that as your base to the 0. Now we've got the same base, and we can drop that base. Move the 6 over, and we get x equals 3. Now, just in case you're wondering, what you could have done is on this, well, even on the first step, but especially on this step, you could have cross-multiplied this over. That would have been another method for solving this. Then you'd have 4 to the x equals 4 to the 3x minus 6 times 1, which is just 4 to the 3x minus 6. Then you've got the same base, drop the base, and you'll get the same value for x. So if that's a little easier for you, you're more than welcome to do that. But multiplying over won't always work. So as you'll see in future lessons, we do need to be able to use this exponent rule here, where we're dividing and then we subtract. But if you saw that, it's a nice little shortcut on this one. All right, let's go ahead and take some notes. So we are just beginning to solve exponential equations. These were our first examples. And the basic method is we need to get the same base on both sides. Then we drop the base. Technically, what we're doing is we are equating the exponents, but it just sounds cooler to say drop the base. And then we solve the algebra. And it's important to keep in note things like you need to know your power table. So you need to know your power table. You need to know your exponent rules. And otherwise, you're pretty much good to go. So here's one for you. We have 25 to the 1 minus 2x equals 1 over 625. Go ahead and pause the video and give that a try. All right, we're looking for powers of 5 here. So that's going to be 5 squared. That's going to be 5 to the 4. So that's 1 minus 2x. Then we write this as 5 to the 2 minus 4x equals 5 to the negative 4. Drop the 5s. 2 minus 4x equals negative 4. It's going to be 6 equals 4x. Kick the 4 to one side, the negative 4 to the other. So x equals 6 over 4, which is 3 over 2. Now, for your own practice, you can try something from Unit 8, Worksheet. We actually did two, Worksheet 0 or Worksheet 1. Worksheet 0 is just reviewing those exponent rules from previous years that we need, and then Worksheet 1 is actually these exponential equations. And then write down any things to remember. One thing I would just, again, like to highlight is that negative rule. It's a little tricky for students, but if you have a 1 over anything, x to the, this is the general rule, right? 1 over x to the n, you write that as x to the negative n. So if it's 1 over 7 to the 3x minus 2, you write that as 7 to the negative 3x minus 2. It's important to get rid of those fractions. All right, hopefully you enjoyed this video, and as always, thanks for watching.